Hi guys, we're going to talk about exponential growth and decay today. I think you'll find it very interesting. Now, we're going to talk about the formula first. Here's our formula. Y equals AB raised to the x. Let's talk about each one of them individually. Y is what you're going to end up with in the end. That's the number we're trying to find. That's our total bacteria, dollars, whatever the equation was about. The A is my initial amount. That's what I started with, like $3, 800 bacteria, whatever it was that we started with. The B value is my exponential factor. It is either growth or decay. It is growth if it is greater than 1, and it is decay if it is between 0 and 1. And then it is raised to the x. That's what makes it exponential growth and decay. And that's usually in terms of time. Sometimes not, but usually time. That's how I usually like to think of it. So that you need to copy down ever so quickly. Hopefully you've had time to write it down. Y equals AB raised to the x, where A is my initial value, so it's what I started with. And B is my growth factor. So my growth factor tells me if it's growing or it's decaying. Okay, so that's the factor that I'm looking for. If this B value is greater than 1, then it's going to be growth. So for it to be growth, it could be anything greater than 1. It could be 1.5, it could be 2, it could be 7. Anything greater than 1 means growth. But if this B value is, let's just say, between 0 and 1, so it's greater than 0, but less than 1, then it is decay. What would that look like? It could be 0.75, it could be 1/4, it could be 3/8, anything like that, anything between 0 and 1. That would give us decay. Now, let's look at some examples. We have y equals 3, 5 raised to the x. So let's look and break this down for ourselves. First, let's look at where it initially started. What is my initial value here? The 3. So I initially started with 3 amoebas, $3, 3 bacteria, 3 whatever it is. This is my initial value. Now, my next question is this growth or decay? Now, in order for me to figure out if it's growth or decay, I need to look at the base. Okay, remember this is an exponent, it is being raised to the x value. And is that B value, the 5, is that greater than 1? Yes, it is. So therefore, this is growth. What is the factor? It is by a factor of 5. Let's look at another one very quickly. Just draw a line so you know it's a different problem. Y equals 2 raised to the x. All right, so what is the initial value? Remember, the initial value is what's in front of here. What is in front of here? Well, nothing's in front of here. Well, what do we have to know is there that math teachers will not write? A1. We have to know that there is a 1 here. So my initial value is 1 here. Okay? Here, we're going to look at our factor. Our factor in this case is 2. So if I have a factor of 2, is that greater than 1? Yes. So therefore, this is growth. Let's do another one over here real quick. Y equals 1/4, 1.5 raised to the x. Let's analyze what this means. What is the initial value? The initial value is 1/2. Maybe half a dollar, maybe half an amoeba, maybe 500,000 amoebas. I don't know. What is the growth factor here? What is the factor that we're using here? the factor we're using is 1.5. So is it growth or is it decay? Is it greater than 1? Then it's growth. So this is growth because of that 1.5. What is the factor? 1.5. What is the initial value? 1/2. So this is the same, but they've written it just a little bit differently. It actually, to me, is a little easier once you understand it. Let's look at the initial value first. The initial value is $1,200. $1,200, 1,200 amoebas, 1,200 bacteria, whatever it is. This is what we started with. Okay, so that's my initial. Now, my next question is this growth or decay? When I take this number and I add it or subtract it, we'll show you in a second, together, what do I end up with? 1.3. Well, 1.3 is greater than 1, right? So if it's greater than 1, I didn't orange it for you. If it is greater than 1, then this is growth. But now I'm going to ask you another question about this. If this is growth, what is the percent of growth? Well, what's nice about this is they actually tell it to you, but you might not actually see it. Whatever this is here gives me my percent. Okay? So the 0.3, remember, if we have 0.3, we multiply it by 100, because percent is always in terms of 100, and we would get 30. Or you do the math little trick of moving it over 2 places on the decimal. Whichever, we don't care. So that tells me that it is 30% growth. Why is it 30% growth? Because this is 30%, and the 1 represents just repeating itself. What's 1 times 1,200? 1,200. What's 1 times 99? 99. What's 1 times anything? Whatever it is I'm multiplying by. So this 1 actually doesn't even kind of count. It just keeps this going. This is where it's either increasing or decreasing. Now let me show you one that's decreasing. Let's suppose I have y equals 0.5, open parentheses, 1 minus 0.9 raised to the x. Okay, so let's look at initial. Here is my initial value. What is my initial value? 0.5. So that's my initial. And what is my factor? Well, I have to combine these two. But notice what I see here. I see a subtraction. Be very careful. What do I end up with when I combine those two? Okay, so I get a 0.1, right? 1 minus 0.9 would be 0.1. So is this growth or decay? This is decay. It's less than 1, isn't it? And greater than 0? That was the rule I told you. Now, what is the percent decay? Well, I need to look right here, and I can pull that out. Remember that it is decay because of this subtraction sign. That subtraction sign told me it was decay. What is the decay? Well, the decay is 0.9, and 0.9 times 100 is going to be 90%. So my percent decay is 90%. Every time I run whatever this is in terms of days, hours, whatever, then I decay by 90%. So if I started off with $1 and I decay by 90%, I would have 10 cents left. If I decayed by 90% again, let's just say every day, I'd be down to a penny. Every time I decay, it's 90% off of that. So for the growth and decay in that form, these are the way the formulas would look, where y equals the initial amount, 1 plus the r, which is the rate, which was that either growth or decay. In this case, it's growth because it's plus, raised to the x. Here, it's the exact same thing, but the only thing is we change it to a subtraction because we're decaying. Again, y equals a being the initial amount, 1 minus whatever the rate is, the minus giving me my decay. I'll give that to you for a second. You can copy it on your own so that you have it in your notes. So here I'm given a problem. It's y equals 2 times 2 raised to the x. First of all, its initial value is 2. It is growth because it is greater than 1. And my growth factor is 2. So that gives me everything I need to know. I am asked to create a table. So I'm going to create a table real quick, and then I'll also graph it. So we've got x. What I did was I created the table real quickly. I used x values of -2, 1, 0, 1, and 2. I just picked simple numbers. I always start with the center of 0, and I go out 1 in each direction. I'm just looking for simple numbers. We don't have to recreate the world. We don't have to drive ourselves crazy. It's not about that. We're trying to find simple numbers so that we can graph this really quickly. So now I'm going to take 2 raised to the -2. Where did that -2 came from? Right here. Remember, this is my x value. There's my x value, and so I put the x value in as -2 for that particular line. When I do the math and put it in my calculator, if you have a phone, you have a calculator, I get 0.5. So for the next one, I'm going to take this and I'm going to put in 2 times 2 to the -1. And again, when I put that in my calculator, I get 1. Where did the -1 come from? Right there. It was my x value. And then just put it in your calculator, quick crunch of the numbers. Now I'm going to do 2 times 2 raised to the 0. Where did the 0 come from? Right here. Remember, I always pick out 0 because it's an easy number for me and just kind of makes sense. And when I spit that out of my calculator, I will get 0. Next, I'm going to do 2 times 2 to the first, and that will give me 1, 2, 4. Where did that 1 come from? Right here. And then the last one I'll do for this particular example is put in 2 to the 2, and that is 8. Where did that 2 come from? Right there. So that should be pretty easy for you to do. The next thing I'm going to ask you to do, I'm going to back my thing out, I'm going to graph it right next to it. So we'll just do that really quickly, and we'll just plot out a quick graph. So I real quickly created a graph, so now I'm just going to plot my points. Here I have -2.5. -2.5 is about there. Then I've got -1, 1, that's right there. I've got 0, 2, that's right there. I've got 1, 4, that's right there. And I've got 2, 8, and that's right there. Now that you've drawn that, you can kind of see if you look at it, but I can connect these lines, and I have created my little graph. It is an exponential growth because it goes up, okay? As time goes on, it's getting bigger and bigger. It gets bigger really fast. That's what's interesting about exponential growth, is if it is an exponential growth, it means that things are multiplying up and it gets really big really fast. So this is heading really quickly towards infinity. This line is actually never going to hit 0, okay? And because it's never going to actually hit 0, we call it an asymptote. So it has an asymptote. It is never actually going to approach 0. Now I'm going to show you how to do this on Desmo, and you're going to love this, so give me a sec. Okay, so I'm going to type in y equals 2 times 2 raised to the x. Whoops, didn't get the raise. Raised to the x. There it goes. Okay, so you can see their graph looks exactly like my graph. Now, what's really cool about this is you up here to the wheel, you hit table, and it gives me the table. So I can see the numbers that I had to calculate before. Sorry, moved that. I can make that a little bigger so you can see it a little better. Now I can look at the points, -1, 1, and I can touch right here, and I can see that's -1, 1. At 0, 2, it's right there. And at 1, 4, it's right there. Exactly the numbers I came up